The next chart is the Mollier diagram. So this is the Mollier diagram. As you can see, on the x-axis, it's got the entropy, specific entropy, which is in kilojoules per Kelvin kg. Then we've got the enthalpy, which is in kilojoules per kg, the specific enthalpy. Then over here, if you can see, this is the saturation line, meaning where it turns from liquid stroke gas to fully gas. So as you can see, from here it's increasing, the quality is increasing in these red lines. Then and then on the saturation line, the quality is 1, x is equal to 1, as you can see. Then as you can see, these blue lines in here, these blue lines are the pressure. So this is the pressure, these blue lines in here are the pressure, and the pressure is in bars. If you can see, it starts from 0.01 bar, 0.02 bar, and please note that these are not uniform. As you can see, the increase from here is 0.2 to 0.5, then to 1, then to 2, and to 4, until it reaches 500 bars. Please also note that the green lines in here represent the temperature, which is in degrees Celsius. So this Mollier diagram is for water, steam, I could say steam and water. So when it's in this phase, when you're in this phase, you're into the steam and we're into the two-phase region. Then in this part, you're into the one-phase region. So let's say if you have a liquid, if you have a gas that's being cooled down, let's say for example there's this gas here. If you have a gas at 150 that is being cooled down at the same temperature, which is 150 degrees Celsius, so what happens is it gets cooled, it gets cooled, it gets cooled until it reaches the saturation line. Once it reaches the saturation line, be aware that it will be on the same temperature and pressure until it turns to fully liquid. So when you find yourself in an instance where you have a liquid, where you have a gas that is cooling, please be aware that once you reach this line, it means that you're supposed to follow the pressure line, as the temperature and pressure will remain the same. Okay. Again, maybe if we have an example, let's say we're saying we want to find the entropy and the enthalpy of water at 200 bar and 700 degrees Celsius. So what we can just do is just come here, follow the 700 degrees Celsius line, which is there, and then we also reach the 200 bar line, which is here. So from here we just look to the left. When we look to the left straight, this is the enthalpy line. So this is the enthalpy line. It means that the enthalpy here will be 3000. This is 3500. So we have 3637, 3800. So the enthalpy will be 3800 kilojoules per kg. Then when we come down here, when we come back and we look down, we're going to look at, this is the entropy, this will be the entropy. The entropy here will be about 6.7 or 6.75 approximately kilojoules per Kelvin kgs. Okay, so you might be given any value, you might be given any of the two values between pressure, entropy, enthalpy, the quality, the temperature, whichever values you're given. If what you're being asked for is on this chart, you can use this chart and you can mainly use it to find the enthalpy and the entropy.